On cam. Langsung ya, siapkan kertasnya. Langsung siapkan kertasnya, tulis identitas lengkap, nomor absen. Kita langsung mulai ya, biar nggak buang-buang waktu ya. Ayo yang masih off cam, kita langsung ya. Sudah kelihatan gambarnya? Sudah ya?
Iya, Bu.
Bentar, suaranya saya agak keraskan. Ini video pertama ya.
After 4 arduous years of collecting animals in the Amazon jungle, Alfred Russel Wallace is finally heading back to England. Sailing with him are the rewards of a long journey. Thousands of specimens he will sell to museums and collectors. Exhausted from his travels, Wallace is looking forward to the comforts of home.
I'm afraid the ship's on fire.
Permisi, Bu. Permisi, Bu. Halo, Bunita. Bu,
Kenapa?
ini kok putus-putus ya? Nggak tahu di saya doang atau teman-teman yang lain juga putus.
Putus-putus.
Ya, putus-putus, Bu, di saya.
Di sini nggak putus-putus ya? Sinyalnya mungkin. Kalau dari sini nggak putus.
Saya juga putus-putus, Bu.
Sinyalmu berarti. Di sini lancar masalahnya. Saya ulangi lagi ya.
Sailing with him are the rewards of a long journey. Thousands of specimens he will sell to museums and collectors. Exhausted from his travels, Wallace is looking forward to the comforts of home.
I'm afraid the ship's on fire.
every one of Wallace's specimens is destroyed. His hard-earned records of which animals live where in South America are also lost. These notes contain clues to the question that Wallace risked so much to answer. It was the greatest scientific mystery of his time. Where do species come from? But now Wallace's thoughts must turn to a more urgent concern: survival. His hands are burned raw from sliding down a rope. His lifeboat is leaking badly. The castaways have little food or water and are 700 miles from the nearest shore. Wallace vows that if he survives, he will never sail again. This is the story of the search for the origin of species and of the epic adventures of the two explorers who found the answer.
Alfred Wallace might have avoided his predicament had someone else not been keeping a secret. Another British naturalist had already answered the question of the origin of species years earlier, but he had dared to share his ideas with only a few trusted friends.
Charles Darwin set sail on his own voyage 20 years before Wallace's shipwreck. He was an unlikely revolutionary. He lived in a time when most scientists believed that each species was specially created by God in its present form and constant, and not somehow the product of natural laws and changeable. At the age of 22, Darwin also believed in special creation. He was even planning to become a clergyman. But then he got a surprising offer. Darwin jumped at the chance to sail around the world on a British naval vessel, the Beagle.
The offer was more about his pedigree than his resume. Darwin could be cheerful, upper-class company for the captain. No small task, given that the Beagle's previous captain became despondent and shot himself. The lure for Darwin? He was a passionate amateur naturalist, and now he'd have the chance to see and collect animals, plants, and rocks around the globe.
Early in the voyage, he examined plankton with his state-of-the-art microscope, an instrument that only the son of a wealthy family could have afforded. Darwin was perplexed. Why was there so much beauty in the middle of the ocean where no one was around to enjoy it? Why were these forms created for so little apparent purpose? But for every moment of joy or discovery, Darwin experienced 100 of suffering. He was often seasick. Not merely queasy, but desperately, violently ill. His adventure came at a high price. Darwin's curiosity was not limited to science. On the coast of Argentina, he sampled a local delicacy: roast armadillo. He thought it tasted like duck. Not far from this barbecue, Darwin found an interesting fossil. It was a small piece of an extinct creature called Glyptodon. It was part of its protective covering. Darwin had seen a similar bony shell on the armadillo he had just eaten. But this fossil came from a giant. The animal he discovered would have been dinner for 1,000.
Darwin found several more fossils nearby, including ground sloths like this one. They were all enormous compared to living species. Darwin would ponder the geological relationship between the extinct and the living.
Darwin didn't yet understand why fossils of extinct animals turn up where similar animals live today. After nearly 4 years at sea, twice as long as Darwin had signed up for, the Beagle arrived in a remote Spanish colony, the Galapagos. It would have been the dream of most any naturalist to explore these islands. But when Darwin arrived, he was more exhausted than excited. If hell had a garden, he thought, this is what it would look like. The black volcanic rocks felt as if they'd been baked in an oven. The plants stank. He didn't see a single beautiful flower. The Darwin that arrived here was not the great theorist that we know today. He was a 26-year-old collector, collecting really almost at random any kind of plants, any kind of animals, any kind of rocks. He didn't even know the meaning of what he was collecting until much later. He thought the island's seagoing iguanas looked dim-witted and hideous. But he did like a different Galapagos reptile, the tortoises. He even took a ride on one.
You magnificent beast. When Darwin was here in the Galapagos, he was given an important clue. The Spaniards told him that they could tell which island a tortoise came from just from the shape of its shell.
Why would tortoises on nearby islands look so different from one another? The island's mockingbirds also caught Darwin's attention. He focused on their subtle differences. One kind of mockingbird had smudges on its breast. Another had a large dark patch under each eye. A third had a pure white breast. Darwin was astonished when he realized that, just like the tortoises, each kind of mockingbird lived on a different island.
So even though he stayed here just 5 weeks out of the whole 5-year voyage, it's what he saw here in these 5 weeks that left the greatest impression on Darwin and would lead into his greatest ideas.
After stops in Australia and Africa, and as the Beagle turned home to England, Darwin had the chance to reflect on what he'd been seeing. In his cabin, Darwin puzzled over the Galapagos animals. It was remarkable that similar but distinct creatures lived on such nearby islands. What would explain this fact? According to special creation, God made a different species for each island. But another possibility occurred to Darwin. Perhaps one species might have come from the mainland and then changed in different ways on different islands. The Galapagos animals were raising a radical idea. Species might change. After Darwin returned to England, he starts thinking about everything he saw on this 5-year voyage. And he's thinking back to the geology, the fossils, the animals that he'd seen. And he's in this process he calls mental writing, just letting every thought stream to him until finally he has his big idea. Rioting was the right word. His ideas were doing violence to the established order. The best explanation for what Darwin saw in the Galapagos was that species changed into new species. Over time, one kind of mockingbird somehow became 3. Tortoises multiplied into different forms.
And what did it mean that armadillos and sloths live today where extinct giant versions once roamed?
Maybe, Darwin thought, today's species are descended from older, extinct types. If so, then all species are connected to one another in a family tree. It is a simple, crude sketch, but Darwin's drawing is a radical, new picture of life. Any species can give rise to new and slightly different species. As generations pass, grand species arise, and then great-grand species. Darwin's bold idea was that species come from other species just as naturally as children come from parents. There was a word for this kind of thinking: heresy.
So the origin of species was natural, not divine. It was a revolutionary idea that overthrew special creation. It ran against church teachings and what most Europeans believed, including most scientists. Still a young man, Darwin couldn't reveal his great idea. He would be attacked and ruined.
Many years later, Darwin's popular account of his voyage is a big success. He's published 6 books and has become England's most prominent naturalist. But he is still keeping his biggest idea secret. Darwin is gathering yet more evidence for his theory when at a museum he encounters an earnest young man.
I've read your work, Voyage of the Beagle. It is excellent and inspiring. Thank you very much. I'm
Wallace had survived his ordeal at sea.
to do some research.
After 10 miserable days in a lifeboat, he had been rescued by a passing ship.
Both to my notes before I leave.
Wallace and Darwin are meeting for the first time. The 2 explorers share a great passion for nature. but they are in very different situations.
I'm headed to the Malay archipelago to do some research.
Oh, excellent.
I'm here
Wallace is single. He has to collect for a living, and he has yet to make his mark.
Yeah, so now I've never been there. Are you collecting? What?
Yes, I'm...
Darwin is married and has a family. He is financially well off and has a scientific reputation to protect. Wallace is as open as Darwin is secretive about his interest in the origin of species. Little does Darwin know that this young man will soon force his hand.
I could send you back some specimens if you'd like.
Oh, very much so, yes. Thank you. But please, no barnacles. I've just finished a work on barnacles that...
And Wallace doesn't have a clue that Darwin has already scooped him.
Have you written anything yourself?
Believing that the question of the origin of species is still wide open, and despite having nearly lost his life at sea, Wallace sets out on a new voyage. He travels to the region between the Pacific and Indian Oceans, the Malay archipelago. For the next 8 years, he will collect and study animals as he hops from island to island in a 14,000-mile journey. Wallace is captivated by butterflies. His favorite group is called birdwings, after their shape and large size. They command a high price for their striking colors. He finds birdwing butterflies throughout the archipelago. He identifies new species, some that are slightly different from those on nearby islands. The Malay butterflies suggest to Wallace what the Galapagos animals revealed to Darwin. Species change. But Wallace, too, seeks to understand the bigger picture. Having explored jungles on opposite sides of the globe, he can compare where different groups of animals live and ask why they are found where they are. Wallace the collector now becomes Wallace the theorist. Birdwings occur near other species of birdwings in the Malay archipelago. Across the globe, in the Amazon, live different families of butterflies. Bird families also cluster geographically. Cockatoos live only in the Malay archipelago and Australia, whereas the Americas are home to macaws and hummingbirds. Around the globe, the more similar two species are, the closer they tend to live. Why is this so? Wallace formulates a new law of nature. It's about where new species arise. They don't appear in random places. They arise near similar species. He realizes the profound implication that species are connected to one another, like the branches of a tree. On his own, Wallace arrives at Darwin's still secret tree of life. Wallace finds more evidence that all species are related by considering some intriguing creatures. Manatees are mammals that live entirely in the sea. But inside their flippers are finger bones. Similar, apparently useless bones are inside whale flippers too. If God had created these animals from scratch, wouldn't he have skipped the fingers? Imperfections such as these vestigial structures make it clear that every species is a modified form of an older species. Zigzagging across the Malay archipelago, Wallace gathers critical evidence for his law. On the island of Borneo, he sees monkeys and orangutans. But elsewhere in the archipelago, in New Guinea, the mammals are strikingly different. No monkeys here. Instead, up in the branches are tree kangaroos, marsupials, whose young grow up in pouches. Island by island, Wallace notes which of the two groups of mammals lives there, those with pouches and those without. Animals on the eastern islands resemble those of Australia. Animals to the west, those of Asia. It's as if a line splits the archipelago. It will be dubbed the Wallace Line.
Why would God draw a boundary through these islands and put monkeys in the trees on one side and put kangaroos in the trees on the other side? This made no sense. Special creation couldn't explain the line, but Wallace's earlier law could, that species come from pre-existing nearby species.
The eastern islands of the Malay archipelago, Wallace surmised, were once connected by land to New Guinea and Australia. So animals like kangaroos could hop on over. The western islands were never connected to the eastern ones, but they were connected to Asia. So the west had different mammals, ones with placentas instead of pouches.
It's the history of the planet, not special creation, that explains the distribution of species.
In Wallace's time, geologists understood that natural processes, such as volcanism and erosion, could change the shape of islands and continents. But what about species? How do they change? That is Wallace's next question. As a collector, he has a great eye for detail as he chooses specimens to sell to his customers. He knows that among all living things, from butterflies to snails, individuals within a given species usually vary in small ways. But what does that variation have to do with how species change? The answer comes to Wallace during a high fever. He must have been thinking about the very real chance that he would die. He recalled the English economist Thomas Malthus, who noted that human populations are held in check by famine, disease, and death. Wallace realized that was even more the case in nature. Without death, any species would quickly overrun Earth. But animal populations tend to hold steady. That's because huge numbers of young die every generation. Two facts now snap together. Massive death plus variation. Wallace now sees how species could change. Those individuals with variations that give them even a slight edge will survive, reproduce, and in time outnumber those without the advantage. His is a fundamentally new picture of nature, of intense, even violent competition. Wallace thinks he might have an important new idea, but he wants a second opinion before publishing. He knows just the right person to ask, thousands of miles away in England.
Excuse me, sir. This just came for you.
Ah, yes. Thank you.
Sir.
Darwin is shocked. He couldn't have written a better summary of his own theory of how species change. He called it natural selection than what had just arrived from Wallace. How could this happen?
Both men had observed slightly different species on nearby islands and concluded that species could change over time. Both had collected huge numbers of specimens, casualties. Same fact patterns, same explanation. Great minds think alike.
Oke, silakan 15 menit untuk buat analisa video yang pertama. Mulai ya video 2 ya.
Beetles alone. 17,000 butterflies. Thousands of mammals, fish, and birds, all astonishingly different. How did so many species come to be? To seek insights into that question, researchers are focusing on places where species recently arose, such as the remote Galapagos Islands.
Scientists are making observations and conducting experiments that would have surprised Charles Darwin. And they're discovering new insights into what the great naturalist called the mystery of mysteries: how new species form.
The Galapagos Islands are one of the most spectacular landscapes in the world, home to a variety of species that live nowhere else. Biologists Peter and Rosemary Grant have been seeking answers to how species arise by focusing on one of the smaller islands called Daphne Major.
When we started out, we had no plan for the long term. In fact, we thought it was just going to be just a few years, maybe 2 years.
2 years
Bu.
Into how adaptation occurs came when the grants focused on one species on the island of Daphne Major.
A factor of great convenience for us was the small size of the island. That meant that we could walk all over the place.
Oh, there's a bird.
I'll leave that one to you.
The idea was that if we worked really hard, we could follow every individual or almost every individual.
They rose at 5:30 each morning to net the island's medium ground finches.
The beak depth is...
They measured the size and shape of each bird's beak, the bird's weight, and they tagged them for identification.
The male is 17418.
Year after year they returned, at times tracking over 1,000 finches.
So here's an example of a bird we know intimately over the whole of its lifespan. The number is 5960. We know how many times it bred, which years it bred in, how many mates it had, how many offspring it produced, and then how many of those offspring themselves survived long enough to breed.
Over the first 4 years, little seemed to change. Then in 1977, a terrible drought began.
Virtually no rain fell for the next 18 months.
The vegetation practically disappeared, apart from a few trees without any leaves, and of course the cactus bushes were still there.
Now the medium ground finches had to compete for scarce food.
They started off with a big food supply of small seeds, medium seeds, large seeds. As these small seeds became very scarce, they had to turn increasingly to the large and hard seeds. Well, only birds with large beaks can crack open these woody, spiny fruits.
The birds with the smallest beaks had the most trouble.
They were scraping about amongst the rocks, and their plumage got so worn that they could barely fly.
That year, over 80% of the medium ground finches died.
We would go around looking for birds that had died, and it's very sad to pick up a bird and say, 3972. Oh, no, not that bird. Oh.
When they inventoried the surviving medium ground finches, they discovered that one trait had made the greatest difference between life and death.
Well, I'm showing here a distribution of beak depths of the population in 1976. The survivors of this group are shown in black.
Oh. So the larger the beak, the better your chances.
The larger the beak, the higher the likelihood of surviving through the drought of 1977. 18.6 grams.
When they looked at the offspring, they found an even greater surprise. The average beak depth was more than 4% larger than the previous generation. Natural selection had changed the average beak size.
Could you have ever imagined measuring and observing something like this on such a short time scale until you actually did it?
When we started, the answer is no. We could not imagine we would be able to do it.
But was this a fluke? Or are changes like this happening all the time? 5 years later, in 1983, an unusually strong El Nino brought 10 times more rain than normal. And the island was overrun by vines that covered even the cactus. The rains changed the vegetation on the island, such that 2 years later, when drought struck, larger seeds became scarce. The birds with larger beaks now had difficulty picking up the more abundant food, the small seeds produced by the vines. That year, many more finches with small beaks survived, and their offspring inherited smaller beaks.
So the selection had swung in the opposite direction, and evolution had occurred as a result.
In an amazingly short period of time, the Grants had measured evolution of beak size not once, but twice, demonstrating that when birds encounter different environments, they will change over a very short amount of time.
Over millions of years, changes like these, occurring throughout the Galapagos, generated all sorts of beak sizes and shapes. But that's only part of the story. How did finches with different beaks become distinct species? Species are defined as populations whose members don't interbreed.
So how does one species split into two? A typical scenario is that two populations become separated geographically and undergo enough change in their respective habitats that if or when they come into contact again, they do not mate.
So in the Galapagos, the Grants asked, what keeps different species of finches from mating?
We were very conscious that on any given island, the different species sing very different songs. This is what a cactus finch sounds like. Whereas the medium ground finch sounds very much like this.
So to see if songs keep the species apart, the Grants and their student Laureen Ratcliffe played each species' songs through a loudspeaker.
When we played back the cactus finch song, cactus finch came to the loudspeaker and the medium ground finch completely ignored it.
The males only responded to songs of their own species. The Grants looked at whether finches might also choose mates based on appearance. So they put out stuffed female specimens to see if males would respond.
Clearly they could discriminate. The male vigorously courted a female of his own species, completely ignored the other one.
The males only courted females that had a similar size and similar beak. Song and appearance both play a role in keeping different species from mating. So when populations of the same species are separated, changes in these traits set the stage for the formation of new species. The Grants have shown that both geography and ecology are keys to the evolution of the Galapagos finches. The most likely scenario is that 2 million years ago, a single finch population arrived from the mainland. When their descendants reached another island, they faced new conditions. As those isolated populations adapted to their surroundings, their traits changed. If the changes included traits involved in mating, and the populations came into contact again, they no longer mated. They had become distinct species. While unique to these remote islands, the history of the Galapagos finches offers a general insight into why the world is populated with so many species.
The more diverse the environment, the more opportunities for evolutionary change to produce those new species.
Over 150 years after Darwin first recognized their significance, these unassuming birds still illuminate how the great diversity of life arose and continues to evolve.
Baik, sudah selesai ya videonya ya. Kalau sudah selesai, nanti langsung dikumpulkan di SLC ya. Di situ sudah ada deadline-nya jam berapa. Difoto, terus dikirim ke SLC. Ini sepertinya tidak ada yang pimpin doa sentral. Kita doa secara pribadi aja ya. Minta tolong Kevin. Kevin.
Ya Bu, halo Bu, ya.
Ya, pimpin doa, Vin.
Oke Bu. Teman-teman mari kita berdoa. Dalam nama Bapa dan Putra dan Roh Kudus, amin. Tuhan Allahku, terima kasih karena Engkau telah membimbing kami selama pelajaran pada hari ini. Terima kasih karena Engkau telah menemani kami hingga siang hari ini. Sekarang kami mau melanjutkan kegiatan kami masing-masing di rumah. Berkatilah kami agar kami dapat selalu selamat dan terhindar dari segala penyakit. Amin. Dalam nama Bapa dan Putra dan Roh Kudus, amin.
Oke, terima kasih. Ya, selamat siang.
Terima kasih Bu.
Terima kasih Bu.
Terima kasih, Bu.
Terima kasih Bu.